Hello everyone, I hope you are doing fine. This is going to be our second chapter for IMAT chemistry. So we will be discussing about ideal gas laws and the periodic table. So this chapter is one of the most important chapters for IMAT because all the three topics that we will be discussing are like the gold mine of MCQs. From these topics there are going to be 100% MCQs. As you can see, there were 6 past year questions from ideal gas laws, 5 were from periodic table, and there were 9 questions from periodic trends. Like periodic trends have questions like every year. There has been no year in IMAT in which periodic trend has not been a question. So you have to be understanding like these are the one of the most highest yield topics that you will be studying in IMAT chemistry. So let's take a screenshot of the most high yield topics that we will be discussing in this chapter. Take a screenshot and we will start our lecture. Okay, so the first topic that is about Boyle's law. So many students are actually really skeptical because they think that why are we studying like so many basic things. The reason is that because we have to start from the basics and then we have to go towards the more complex questions, because in IMAT most of the questions are sometimes really basic and many students forget basic concepts when they are studying a really high complex. For example, like if they are studying about how K constant changes when temperature changes, like this is a really high and complex question, but they forget that they have to apply Boyle's law in certain situations, and they also forget that they have to apply Choules laws, and they also forget that the MCQs is not about ideal gas or non-ideal gases. So you have to keep in mind like the basics are really important in IMAT, because if your basics are strong, believe me, IMAT is going to be a piece of cake for you. And if there are highly complex questions, we will be discussing at the level of IMAT. Like if they are asked about complex questions, then we will discuss all the complex and high yield concepts that could be taken out from these topics. So the first thing is that what is an ideal gas? So ideal gas is like a gas like that have no volume, that have no intermolecular forces, like it is fictional, it is not real. So that's why it is called ideal gas. It is like a perfect gas, while non-ideal or real gases like have volume, they have intermolecular forces. So that's why ideal gases are different from real or non-ideal gases. We will discuss them in detail in our end of the chapter. So the first thing that you have to know about these questions is that the first thing that you have to do solving ideal gas questions is that you have to convert Kelvin into degree Celsius. This is the first and most important step that you have to take. Like first of all, convert degree Celsius into Kelvin. If you are not converting, then the answer is always going to be wrong. We will be doing these kind of questions in our past papers in which the answer is absolutely insanely different, because in so many cases, like for example, if I give you a question and in statement the temperature given is 293 degrees Celsius, this is an example, and the options are also 5 degrees Celsius, 4 degrees Celsius, 3 degrees Celsius and 2 degrees Celsius. And so many students will say like, yeah, because the options are in degrees Celsius, I don't have to convert the temperature into Kelvin. But that is a big mistake, because you have to convert the degree Celsius into Kelvin, because these formulas that we will be discussing in our later lecture, they can't use temperature in degree Celsius. These formulas need temperature in Kelvin. So even if the options are in degree Celsius, the first thing that you have to do is that convert degree Celsius into Kelvin and then use that temperature and solve the question. After you have solved the question, you will get answer in Kelvin. Then convert Kelvin back into degree Celsius. So that's how you can solve these kind of questions. And if the answer is in Kelvin, then you already know that you have to convert degree Celsius into Kelvin first. So this is the thing that you have to keep in mind, that even if the answers are given in degree Celsius or Fahrenheit, you have always have to convert the temperature into Kelvin. The next thing is that pressure units cannot be consistent. Like you have to make sure that the pressure units are consistent on the both sides of the equation. Same is for the volume. You have to know that if the equation has liter in one side, then you have to use liter in both other side too. So the units should be consistent in your whole calculations, or you will get the answers wrong. The next thing that you have to know is that if one variable is constant, then use simple form of the laws. But if there are three variables that are different, then you will use combined law. So what are combined law and what are single laws? The first three single laws are Boyle's law, Charles' law and temperature law, and the last is the combined law, in which we will combine all these three laws into one law, that is called combined law. So if you have volume different, if you have pressure different, if you have temperature different, then you will use simple laws. But if you have pressure, volume and temperature, all of these variables are changing and different, then you will be using the combined gas law. So that was like the introduction about how you will use these laws in your IMAT exam, because you are not here to revise your intermediate and in the 11th 12th, you are here to prepare for IMAT. So you have to take these kind of lectures so that you are prepared for IMAT, not for an A levels exam or your high school exams, because you are here to prepare for IMAT. So you have to understand these topics in accordance with how IMAT will ask questions from these specific topics. So the first law that we will discuss is about Boyle's law. So in Boyle's law, the first thing that is constant is temperature, and the second thing that is constant is volume. In Boyle's law, you study the relation between pressure and volume. So what does the Boyle's law tells you? The Boyle's law tells you that volume is inversely proportional to the pressure. That means if you increase the pressure, then the volume will decrease. Like this is a high school level basic concept, right? Everybody knows that if you increase the pressure on a gas, then its volume will decrease. You can also write the equation in this way. You can also write it V equals K divided by P. So the equation can be written down in this form too. So these are the three ways that you can write down Boyle's law. If you can see, if you have two different gases, the first gas has volume 1 and the second gas has volume 2, then you will use this formula, that is P1 V1 equals to P2 V2. So this is the formula for Boyle's law. It tells you the relation between pressure and volume. If you increase pressure, the volume will decrease. If you decrease pressure, then the volume will increase. So that's what Boyle's law is, and that was the basic. Let's discuss some deep concepts. The first thing that is, you have seen that there is a constant that is here, that is called K. So that is Boyle's law constant. So what does it depends upon? The K actually depends upon the things that are constant here. So what are the things that are constant? As you can see, the first thing that is constant is amount of gas, right? Or you can say mass. So the mass is constant. What is the other thing that is constant? The other thing that is constant is temperature. So K depends upon mass, or you can say amount of gas and temperature. And the third thing that K depends upon is nature of gas. If you change the nature of gas, then the K will obviously change. So that's how K depends upon three things. It depends upon mass, temperature and nature of gas for Boyle's law. And the next thing is about the graph. If you make a graph between pressure and volume, then the slope will be called as isotherm. As you know that pressure and volume are inversely proportional to each other, then the slope that you will get here is just like this. So this slope is called isotherm. If you keep increasing pressure and volume, then the isotherm will keep going away and away from the graph, just like this. If you increase the pressure again, it will go away like this. So if you keep increasing the pressure and volume, if you keep increasing the temperature, then the slope will keep going away from the graph. So the slope that you are getting here is called isotherm. Why is it called isotherm? Because iso means same and therm means temperature. So in this case, in the whole slope the temperature is constant. So this is the slope or graph that you can see is called isotherm. You have studied these kind of graphs in detail in your physics lecture, and now they are really handful in chemistry too. So let's solve an example for Boyle's law. They are saying that a gas occupies 4 liter volume. So first you have to know that if you have 4 liter, then the answer should also be in liters. And you can see that the pressure is 200 kilopascals. V1 has been given, P1 is also given. What volume does it occupy? That means V2 is missing at 400 kilopascals, and P2 is also given. You just have to use the equation V1 equals to P2 V2 and you will get the answer 2 liters. That was really easy. I will be not solving the question because I know you already know how to solve it. Next thing is about Charles' law. Charles' law is the relation between volume and temperature. So the things that are constant in Charles' law are pressure and amount of gas, or you can say mass of the gas. So Charles' law tells you that volume is directly proportional to the temperature. That if you increase the temperature, the volume will increase. So volume is directly proportional to the temperature. You can also write the equation as V equals to KT. V equals to KT. So the K constant here is again Charles' law's constant. So these are the 3 ways that you can write down Charles' law. These are the 3 ways that you can use the formula for Charles' law. So the next thing that you can see here is that V1 is the volume for one gas and V2 for another gas. T1 is the first temperature and T2 is the second temperature, and the temperature should always be in Kelvin. If you talk about K, just like in Boyle's law, the K depends upon the things that are constant. So what are the things that are constant here? The first thing that is constant is mass, right? Or you can say amount of the gas, right? So mass is constant. What about the second thing? The second thing that is constant here is the pressure. So pressure is constant. So that's why K depends upon the pressure. Again, the K depends upon nature of gas. Obviously, K will always depend upon nature of gas, because if you change the gas, the whole scenario will change, right? Because K will have different value for oxygen, for nitrogen, for carbon dioxide. So that's why K depends upon the nature of gas. But the situation is really different if the volume is constant and volume is not constant. The Charles' law is different if the volume is constant and volume is not constant. This example is really important, because you have to understand that if you raise the temperature, what will happen to the volume and pressure, and if you decrease the temperature, what will happen to the volume and the pressure. If you increase the temperature, obviously you know that volume is constant, then the pressure will increase, and if you decrease the temperature, then the pressure will decrease. But you have already studied it in the Boyle's law section. But what if the volume is not constant? What if pressure and volume both are not constant at the same time? Then by increasing temperature, you will get positive change in volume. You will get change in volume that is positive. And what will happen to the pressure? The pressure will actually decrease, because the change in volume will be more than the change in pressure. That's why if you compare the difference, then the change in volume will be positive and pressure will actually decrease. I know it may seem really difficult for you right now, but if you memorize Boyle's law, Charles' law and all these laws, then come back to this topic, come back to this table after you have memorized those laws, then you will understand this law better again. If you decrease the temperature, then the change in volume would be negative and the pressure will increase. So that was about the temperature change and how temperature change can affect pressure and volume when the volume is constant and when the volume is not constant. Let's talk about the graph for Charles' law. If we make a graph between volume and temperature, then you will get a straight line like this. This is a uniform graph and it is called isobar. Iso means same and bar means pressure. So isobar is a slope that is a product that is gained when the pressure is constant. So as you can see, when you are increasing volume, the temperature, if you increase the temperature, then the volume will also increase. So that's how you can see that by increasing temperature, volume will always increase. Why does the volume increase? When you increase the temperature, then the volume will have more collisions and the kinetic energy will increase and they will hit the walls of the container, and slowly the piston will move up if it is a container like this, and this is a piston right here, and these are atoms that are striking with the walls of this container. If you increase the temperature, then they will strike really hard with the piston here, and when the temperature increases, this piston will eventually go up slowly by increasing the temperature. The more heat you will give, the more volume will increase. So these are the basics that you already know. Let's solve an example. They say that a balloon has a volume of 3 liter. You will say that this is volume 1 and it has temperature of 27 degrees Celsius. Okay, so as you can see, the temperature is in degrees Celsius. It is temperature 1. So I have already converted it into Kelvin, so it is actually 300 Kelvin. What is its volume? So you have to find V2. What is the second temperature? What is the second volume when the temperature is 127 degrees Celsius? So as you can see, first you have to convert the temperature into Kelvin. You will get 300 Kelvin and 400 Kelvin. By using the formula V1 over T1 equals to V2 over T2, you will get the answer that is 4 liter. That is the correct answer. So that was all about Charles' law, all the things that you need to know. Let's move on to our next, that is Gay-Lussac's law. So this is the law that finds the relation between pressure and temperature. So as same, just we studied for Charles' laws and Boyle's law, this law can also be written as pressure is directly proportional to the temperature, or you can write it down as P equals to KT. So these are the three ways that this law can be written down as P directly proportional to T, P is equal to KT, or you can say P1 over T1 equals to P2 over T2. Just like we discussed before, K will depend upon what are the things that it will depend upon. First of all, it will depend upon obviously mass. You already know what I'm going to say. It will depend upon volume, and what is the third thing that it will depend upon? Yes, it will depend upon nature of gas. Let's move on to our next topic, that is the combined gas law. So we just discussed that these are the three simple laws, and if there is one single variable, for example in Gay-Lussac's law there was only volume constant, and when we studied about Charles' law the pressure was constant, and in Boyle's law the temperature was constant. But what if there is no variable that is not constant? All the values are like variable, they are not constant, they are changing. Then you will use the combined gas law. You will use all the variables. You will use pressure, volume and temperature combined into one single law, that is called as combined gas law. So for example, if you are given three different values, pressure, volume and temperature, and final pressure is P2, final temperature is T2, and you have to find the final volume, you will use this law P1 V1 over T1 equals to P2 V2 over T2, and you will get the answer 1.33 liter. I don't have to solve that for you, right? I know you are smart. So let's move on to our next topic, that is about ideal gas equation. So ideal gas equation is one of the most important topics. We just discussed all the gas laws, and the gas laws are different and ideal gas equation is different. So Ideal gas equation relates to all the four properties that we just discussed: pressure, volume, moles and temperature in a single equation. So it is telling you about PV equals to nRT. All those gas laws are being used in the ideal gas equation. So first thing that you need to know about ideal gas equation is that these are the variables that are written in front of you. What are their notes? Like pressure is, the units is 1 atm, or you can write it down as 101.325 pascals or 101.3 kilopascals. Memorize these values. They will be really handful in your IMAT exam, because you will have to convert these values a lot. The unit for volume is meter cube. You can also write it down as 1 liter equals to 0.001 meter cube, or 1 meter cube equals to 1000 liters. 1 dm cube is equal to 1 liter. So memorize these conversions. Mole is always equals to mole. Gas constant R has different values. The SI unit for R is 8.314 and other units are 0.081 liter atm per mole per Kelvin. So let's talk about R a little bit. Like, what is R? So you have to know the details about R. So R is the proportionality constant of ideal gas equation. So you can also say that it is the general gas equation constant, like general gas constant. So what is the nature of R? So what is nature of R? So the nature of R is actually energy. That's why R has energy in its unit. As you can see, it has units joule per mole per Kelvin. So joule is the unit of energy. So the nature of R is energy. You can say that the unit is, what is the unit? The unit is energy per mole per Kelvin. This is the unit of R. What does it depend upon? Just like, you know, R constant, it depends on two things. It depends upon, this is a tricky one, okay, it depends upon units of, it depends upon two units. The first is pressure and the second is volume. It does not directly depends upon pressure, but it depends upon units of pressure and it depends upon units of volume. Please keep in mind, it does not depend upon pressure, it does not depend upon volume, but R depends upon the units of pressure, it depends upon units of volume. If the units of pressure and volume are changed, so does the value of R. So what does it mean? Like, as you can see, the value of R here was 8.314 and here it is 0.0821. It can also be 62.4, that is dm cube, and torr per mole per Kelvin. So these are the three units that are used for R, like 62.4, 0.0821 and 8.314. These are three units of R. All of these are different. So what is the thing that is different here? As you can see, the dm cube is the unit of volume, and then liter is the unit of volume, and then joule, there is no unit of volume here. So when you are changing the units of volume or the units of pressure, that is torr and atm, when you are changing these units, the value of R is also changing. So that's why R depends upon the units of pressure and volume. So what does it does not depend upon? It does not depend upon temperature. You have to keep in mind that it does not depend upon temperature. Temperature is the thing that it does not depend upon. Okay, so you have to keep in mind that R does not depend upon temperature. Even if you increase the temperature or decrease the temperature, R does not care. It only depends upon the units of pressure and volume. So how can you write down the ideal gas equation in other ways? Just like we wrote down the Charles law, Boyle's law, they had different forms. Same, the ideal gas equation can be wrote down in different ways. As you can see, N here is mole. So you know that mole has the formula mass over molar mass. So let's write it down here, mass over molar mass and RT. So this is another way you can write down ideal gas equation. For example, if you are given mass and molar mass and they ask you about what is the pressure, you can put down all other values for volume, mass, molar mass and R and temperature, you can find out the value of pressure. You can find out anything. They can ask you about anything from this equation. You can also write it down in another way. Like, let me ask you something. What if you multiply these equations with each other? Let's change these equations with each other. For example, if you have molar mass here, it will go up and volume comes down here under the mass. So what is mass divided by volume? Mass divided by volume is density, right? You can write it down as capital D or small d, it's up to you. You just have to memorize the formula. So mass over volume is density. Molar mass will go and multiply, R and T will go down there and they will divide. So what will you write down? You will get density, that is mass divided by volume, equals PM divided by RT. So that's how you can also write down the ideal gas equation. For example, if you are given density, you are given if you are given pressure, if you are given molar mass, if you are given temperature, if you are given general gas, ideal gas constant, and they ask you find the density, you can use this formula to solve that numerical. So these are all the forms that ideal gas equation can be used. We studied about the nature of R, we studied about the general gas equation and the units. So that was all about ideal gas equation. So let's move on to our next topic, that is about standard conditions. So you have to memorize these conditions. They are really important because in IMAT they are not going to be always telling you about temperature, pressure and volume. They will just tell you that the process is occurring in standard temperature and pressure or room temperature and pressure. So you have to memorize these temperatures by heart. The most cases are used by STP, STP and RTP. Like STP and RTP are more important, while standard ambient temperature and pressure, SATP, is less important. It is like less likely to be appearing in IMAT, but I'm really skeptical and I don't want to leave anything, so I just wrote it down for you. So what is standard temperature? It is standard temperature is 0 degrees Celsius while room temperature is 25 degrees Celsius. The standard pressure is 1 atm, so does the room temperature. The molar volume for standard STP is 22.4, while for room temperature pressure is 24. So you have to know that what is STP and what is RTP by heart. Don't ever forget these values. They are going to be really handy in your IMAT exam. So if you summarize the whole gas laws in one single table, then it is in front of you. You can take a screenshot or you will be getting these notes, so you don't have to worry about that. But I want you to write down all the things that I'm writing down, so it will go through the pencil into your brain, into your long-term memory. Just watching the lecture is boring and you will forget a lot of things. So try to write down everything into your notes that I'm teaching you right now. So let's talk about some extra topics, that is what is ideal gas and what is non-ideal gas. So ideal gas is something that does not obey gas laws. Non-ideal does not obey gas laws, while ideal gas obeys gas laws. Sorry about that. So ideal gas is the one that obeys gas laws, and non-ideal does not obey gas laws. So how does ideal gas and non-ideal gas does not obey gas laws? What is the difference between them? The first difference is that ideal gas does not have force of attraction. There is no force of attraction between ideal gas molecules, while non-ideal have actually force of attraction, and that is how the difference is made in both of these. For example, if it is a molecule here and there is another molecule here, and if they have force of attraction between each other, what will happen? That they might form bond with each other and the gas might slowly convert into liquid, and that is a problem. Why is that a problem? Because ideal gas never converts into a liquid. So whenever you think about the properties of an ideal gas, you have to keep in mind that ideal gas will have to remain gas. It does not have to be changing into liquid. It should actually go against this process, and non-ideal will go towards converting from gas into liquid, because it will form attractive forces. So if you form attractive forces, then gas can be converted into liquid, but ideal gas never convert into a liquid. It will never form force of attraction. That is against its nature. So all the properties that we will be discussing here will be surrounding and will go around this point. So the first point is about the temperature. So if I ask you, when will gas will convert into a liquid? Gas will convert into a liquid at low temperature, right? So you don't want to convert ideal gas into a liquid. So if you want ideal gas to remain a gas, you have to increase the temperature. So for ideal gas, the temperature is high. So at high temperature, the gas will be ideal. And if you want to convert the gas into a liquid, right, then you will decrease the temperature. And when the temperature decreases, then force of attraction will develop and atoms will start coming close, and they will slowly start converting into liquid, and the gas will start converting into a non-ideal gas. What about the pressure? So if the pressure increases, as you know, if the pressure increases, then the atoms will come close and they will form bonds, and when they form bonds, then that means they will convert into a liquid. So you have to decrease the pressure. If you decrease the pressure, then atoms will remain away from each other and the gas will remain ideal. And if you increase the pressure, the atoms will come close to each other and they will be converted into a liquid. What about volume? For ideal gas, the volume is really high. Why is that? Because you have to make sure that atoms are separate from each other, and if the space or the volume between atoms is small, then they will form bonds with each other, they will have attractive forces, and they will become non-ideal. So if the volume is small, if the spaces are small, then the gas will move towards non-ideal behavior. So a gas would be ideal in these cases, and a gas would be non-ideal in these cases. If you decrease the temperature, increase the pressure and decrease the volume, then the gas will behave non-ideal. If you increase the temperature, decrease the pressure and increase the volume, it will behave as an ideal. So what about kinetic energy? As you can say that kinetic temperature is high, so for ideal gases the kinetic energy is high, while for non-ideal the kinetic energy is low. So that was all about non-ideal and ideal. We just compressed the whole concept of ideal and non-ideal gases into this small little table. This table is like comprising all of the concepts for ideal and non-ideal gases. So amazing, right? You can write down so many things, so many concepts into a small table. Let's talk about kinetic energy and temperature for gases. So average kinetic energy is directly proportional to the temperature. We already discussed this. Like if you increase the temperature, then kinetic energy of the gas molecules will also increase. But there is a catch here. You have to know that the catch is that at STP, standard temperature and pressure, or you can say constant temperature, average kinetic energy is always same. Average kinetic energy is same. So even if they are saying that the surrounding temperature is increasing or the surrounding temperature is decreasing, if the temperature of the gas is constant, or if they are saying that the gas is at STP, then that means the temperature is also constant. Then the kinetic energy will remain same no matter what is happening outside. Like no matter how much chaos is happening, the kinetic energy will remain same. So this is the thing that you have to memorize, like kinetic energy will remain same at STP or constant temperature, no matter what is happening outside, no matter what chaos is happening, no matter how many changings are being held outside. What is the other thing that you have to know? That is, for non-ideal gases, that there is an equation. What is the equation? You already discussed ideal gas equation, that is PV equals to nRT, but there is another equation that is for non-ideal gases. That is, the equation could be written down as P plus an square divided by v square, then v minus nb, that is equal to nRT. So this is the equation for non-ideal gases. Weird, right? But this is the equation that is for non-ideal gases. So you have to memorize this equation too. So let's talk about what are the things that are given here. P is pressure. What is A? Let's talk about A. So A is actually force of attraction. What is A? A is force of attraction. While what is B? Actually B is the excluded volume. Why are we talking about excluded volume? As you know that for ideal gases the volume should be small, right? So we have to exclude volume. So when you exclude volume, then the gas will move towards non-ideal behavior. So that's why we exclude volume to move the gas towards non-ideal behavior. So when you exclude volume, the gas molecules will come closer, and when they come close they will start developing force of attraction, that is actually A. And when they form force of attraction, then they will slowly start converting into a liquid. So that's how they will form a non-ideal gas. So this is the equation for non-ideal gas. The thing we just discussed in this portion are minor or low yield topics. The other low yield topics is about root mean square value, or you can say root mean square velocity. The root mean square velocity has formula of 3RT divided by molar mass. So you have to memorize this formula. What is the formula? Is saying that the velocity or the root mean square velocity of a gas molecule is inversely proportional to the molar mass. For example, if there is a molecule that is carbon dioxide and then you have oxygen, which of both of these will have higher root mean square volume? So you will be like, carbon dioxide has more molar mass, right? So it will have less root mean square velocity, while oxygen has low molar mass, then it will have high root mean square value. Then that is right, because root mean square velocity is inversely proportional to the molar mass. So this is a minor, or you can say low yield topic. We try to discuss everything that is related to gas laws. So now you have to understand what are the high yield and low yield topics that you have to understand. The first thing is that ideal and non-ideal are like mid yield. You have to understand these, because without understanding ideal and non-ideal you won't be able to understand gas laws. The other mid yield topic is kinetic energy and temperature. You have to know this concept, that is really important. The low yield topics are root mean square velocity. It is a low yield topic. That's why I didn't went into the detail of the root mean square velocity. You can read it in your Cambridge or your high school level books. It will be a better option. And the other low yield topic is the non-ideal gas equation, that is in front of you, P plus AN square divided by V square V minus NB equals to nRT. It is a low yield topic. It won't be appearing in IMAT, but it is better that you understand or know this formula. Then you have the 4 gas laws. The 4 gas laws are high yield, really high yield topics. So please don't skip them. Practice them as much as you can. So this was all from the first lecture for IMAT chemistry. I will be meeting you in your next lecture, that is about periodic table. Until then, bye bye.